Well, hello and welcome to the third lesson in Starting Python. This one is possibly going to be a little bit longer than the others, simply because I have a little bit more to show or a little bit more to discuss with you. Let's go ahead and start by opening idle. We'll be doing that at the beginning of every video for the foreseeable future. Last time we went over some basic arithmetic, and we went over some new concepts there with the modulo, and we had this weird dot that shows up even when we don't want it every time when we do division, unless we use what is called the integer division. What we were doing is essentially processing data, but that data was hard-coded into the program, and we're going to continue doing that. However, even though we're hard-coding the data in there, we're going to use things to represent data by name, and this is called a variable. And the variable name, I like to think of it as meaning that it can change. A variable can vary its contents, and the way it does that is other code that sort of puts different content into that variable, and that variable is basically just a name and a bucket where a value is placed, and at any point in time you can reach into that bucket and grab what's in there. You can view what's in there. You can put different content inside that bucket. And in some cases, as we'll find out, in the case of arrays, you can add more to that bucket and you can take some away from that bucket. You can take things out of the middle of the bucket, and there's that analogy is sort of breaking apart now. But just think of a variable as a bucket which you put a name on, and at any point in time you should be able to look at the value or what's in that bucket by its name, and you can change the value by its name. So we're going to do this by saying age, and that's the name of the bucket or the variable, equals 30, because I'm 30 at this point in time, unfortunately. And if we want to look at age, we just type in age. Now this is how we do it in REPL, or inside of the shell. If you're inside of a program and you need to look at it, you still type it in, but it's not going to print out that value to you. So a more real example would be print age, and it would give it to us if we were running in a script, which we'll do in a few videos. And again, I keep saying videos, I mean lessons or videos. It's one video per lesson. So now let's do something interesting with age, right? Well, at the moment, we've hard-coded age to be 30. It's going to stay that way for a few more lessons probably, but we can use age inside of our arithmetic. We can say age divided by 2, and it's going to give us 15. We can even say age is equal to age divided by 2. And now, it didn't print anything out. That's because it put that 15 back into age. It overwrote that variable with the calculated value of what that value used to be, what age was, 30 divided by 2. So now if we type age, we'll get 15. This is called mutability. And mutability is the ability to change what a variable contains. So one way of thinking of it as the contents can vary. That is a mutable variable. Python does have something called an immutable variable, which is a very, very stupid thing to call it. Other languages call it that too. But just by definition, a variable should be able to vary its contents. We could have went with a better name. I wish they would have. Maybe call it a constant instead of a variable, which a constant is a thing. So who knows? This variable age can continue to be altered also. We can say age is equal to age divided by 2 again. And if we print age this time, we get 7.5, and we can just keep going down. We can say age equals age divided by 2 again, and 3.75, and we can just keep going and going. Eventually, though, we'll get into some space where it'll no longer be able to give us the correct answer, just because how computers store numbers. We'd have to divide it a whole bunch of times to do that, though. But we can do something else here too. We can say age, and now let's say we want to work with multiple variables. So let's create a new variable called his age is equal to 30. And then we'll create another one called her age, and we'll say equal to 27. And now we want to get their average age, or let's even throw a child in there. Let's go kid age, and we'll say 5. We will now do a little bit of math here. This is the very difficult way of doing it in programming, but we'll calculate the average. And the average, if you remember, is the sum divided by the count. Age average is equal to his age plus her age plus kid age, right? And then we would do divided by 3. But this is wrong, because remember that Python follows order of expression or order of operations. So we need to put in parentheses all of the addition. We need that sum first, and then we're going to divide that sum by 3. So this is the correct way to write it. The other way we could have wrote it would be age AVG, and I just realized I swapped to that on accident. It should be AVG age, but whatever, equals, and we can say his age plus her age plus kid age. And now it's going to hold the total, or the sum of all the ages, and then we would say age AVG equals to age AVG divided by 3. And now if we get our age AVG, 20.66 is the average age. So as you can see, we can give names to things. Instead of writing out in here his age, instead of typing 30, and instead of typing 27 and 5, having no idea what they are, we can actually just drop in the name of that variable in place of the actual value. And at any point in time, we can change that value for his age, her age, and kid age. And let's say we have a family of 5 and we want to calculate the average age of that family. It's fairly simple to do that using these labels. And then, well, if we go to the next family, who also has 5 people in it, we could have person 1, 2, 3, 4, 5. And we could have, without having to swap out the numbers there, we can swap out the numbers of person 1, 2, 3, 4, and 5 and run the code again. And we didn't have to rewrite our algorithm. We just changed the variables at the top of our file, and the algorithm ran without being changed itself. That is wildly inefficient for programmers' sake also, though, because there's other things that we can do in Python that are much better than this, and those are called functions. Let's say you want to have this average age thing to be able to run with different ages, right? So basically what a function is we're going to take this few lines that we just wrote to calculate average age, and we are going to allow Python to store those, and then later in our programs, we are going to call those functions by name. Just like we have a variable, his age, her age, kid age, AVG or average age, we can have functions that we can call, or procedures or routines, however you want to call them, which execute these algorithms or this code given some input. And this isn't like the input we talked about earlier, that was the data that we're inputting. This is inside of our program. We need to be able to pass data around a little bit. We need to be able to give this function, because it's going to be isolated, it's going to be on its own, it's not going to have access to anything outside of it besides what we expressly give it permission to use. So let's get to it. Python uses the word def for define a function, and let's call this AVG, and this is going to be for averaging the age, and we'll call it AVG3 because we're going to take 3 arguments. Let's define those as number 1, number 2, and number 3. And notice that we've done something here that we haven't done in the past. We've used parentheses again, but this time we're not using them for order of operations. We are using them in the definition of a function. This is another use of parentheses inside of Python, and you'll see this in almost all programming languages, and that is for the arguments on a function. Like I said, we have to give it data, and right now we're defining what that function looks like. We're giving it a name, and we're telling Python, here's the variables that we're going to use and that we need you to pass to me for me to run properly. And in Python, we're going to end a line that doesn't actually end. You use a semicolon, and when we press enter this time, it's going to indent our code, and it is going to continue. Notice how it didn't just go to the next line with the 3 arrows. That's because it's expecting us to do something more. And what we're going to do is type in our calculation here, but we're going to add this return keyword, which means that we're going to, instead of it putting it into a variable like age underscore AVG, or printing it directly to the screen, we're going to say whoever called this AVG3 function is going to get that value. That'll be clear here in just a minute, I hope. If not, we're going to go over functions again in the next video because this was sort of just ad hoc. So let's write our single line function this time, or algorithm, and this will be num1 plus num2 plus num3 divided by 3, because that's the total count. We'll do a much better job of this in the future. And then when we press enter this time, notice it goes back to the first line there, and then we're going to press enter again, and now it saved that function. Okay, it's time to use that function. So just to remind you, we're going to say age average is 20.666666 because we gave his age, her age, and kid age to age average. And what we're going to do this time is, instead of writing out that whole equation there, let's just call AVG3, which is our function, right? And we're going to type in the same numbers this time. We're going to type in 30, 27, and 5, and then we're going to close the parenthesis. And now this is new also. Again, we're using the parentheses for something new here, and we had order of operations, and then we had, in the definition of our function, arguments, and now we have parameters that we're passing. I may have reversed that there. One way we call them parameters, the other way we call them arguments. I don't remember off the top of my head right now. As you can see in the clock in the bottom right, it's 2 a.m. My kids are sleeping, so it's quiet enough to record these videos. So AVG3, open parenthesis, and then all of our variables that or values that we're going to pass in, separated by commas, in order that they were defined inside of our function definition. and then close parenthesis. And when we press enter, we get the same exact value as we had in age AVG. But if you notice up on age AVG up here, we had to write it. And if we wanted to do it again, we'd have to write that function out again and again and again. But here, when we wrote def AVG3 and then the return with that, now all we have to do is call this AVG3, open parenthesis, the three variables or the three values, and then we're done. Now, the real power of this comes in because we can say AVG3 and then we can start passing variables as arguments. They don't have to be constants, literals. Literal just means that you're typing in the value hard-coded into the program. That's a literal. So this 3 up here is a literal. This 30, the 27, the 5, these are literals. Up here, this is sort of a literal, but not. We're using a literal to set his age. But down here, we can use literals, we can use constants, and we can use variables. So let's go ahead and use our variables. His age, her age, and kid age. And if I haven't accidentally unset those for some reason, we get the same thing. But now we can do AVG3 and we can just grab 3 random numbers. Oh no, somehow I picked 3 numbers that do the same exact value. Oh man, I know that is not going to give us the same value. What are the odds? Okay, so before I really screw up, let's do this AVG one more time just to make sure. And we're going to say 10, 5, and 5. And we have 6.66. Okay, so that is the average age. We're good. While we're ahead, let's go ahead and stop. Thank you so much for joining me for another lesson. The next video, we're going to get into one of the most powerful parts of just programming, and that is working with string data on the website, StartingPython.com. Thanks.